welcome to our winter school. We're so excited. This is Tamlin, and you guys know that I'm Katlaho. Tamlin will be doing Maths Revision Paper 1 today.
That's right.
And
Lots and lots of functions.
tell us more about those functions that we'll be doing.
Work your way around that Cartesian plane and we'll make you know what you're doing by the end of it.
Awesome, and this is a boot camp, so you guys know that we are serious about life and we are serious about you. So we are here to help you learn more and learn extra, and Tamlin will be dedicated for an hour and a half. You guys asked for long shows.
Yep,
they asked
got
for
it.
longer shows. They got it. You can walk over to your board and just prepare. So you guys know exactly how to get hold of us. And today we have even more exciting ways. So you can choose which way works for you. Number one, there's our Facebook page. You guys know our Facebook page, facebook.com/learnextra. Number two, you can email us. And today will be exciting because we have a competition, guys. A great competition where you can stand a chance to win these lovely t-shirts. Let me walk up and show you. Lovely Learn Extra t-shirts. Also, we'll be giving away CDs. Look at this. Robin Thicke, Love After War, and the FU2 CD. I know that's very exciting, guys. Another thing that we have, there's so many things here, is our revision book. It has past papers. It has questions. It has how to do the questions. It has everything. And of course today it'll be a maths one because this is maths paper 1. And also let me get back to you about that email. With the competition, the question which I'll be giving to you in 2 seconds, there's pep text. And I don't know if you guys know about pep text, but you can download it. And let me show you how to download it. Actually, we'll be posting it on the page so you guys will know exactly how to do it. It costs you only R1 and you can post anything that you wish, especially the answer to our question today. So you must SMS pep text to 32727 and it will download onto your phone. Also, you can email us at win@learnextra and we'll be receiving everything from there. Remember that all your questions, all your answers, you must post on our events page. It's a separate link on the Facebook page so that you guys know that we are here for you today at this point. And remember to go on to the 2nd of June because today is the 2nd of June. And today Tamlin will be answering any questions that you have. So our competition question, are you guys listening? Are you ready for our competition question? The competition question is, what type of function is f of x equals 2x squared? That's f of x equals 2x squared. Tamlin.
And there are 3 options.
There are 3 options also, yes. So the options are A, linear functions, B, quadratic functions, C, hyperbolic function. So that's A, linear function, B, quadratic function, C, hyperbolic function. So make sure that you guys know the question and you can answer it. And let us know your answer, guys, and who you are as well, so that we can help you. Over to you, Tamlin.
Right, well, hopefully by the time we have gone through all of this, you'll know exactly what that answer is, okay? Okay, guys, so today we're going to be doing functions, which includes all of our parabolas, it includes our hyperbolas, our exponential graphs, our log graphs, lots and lots of graphs over here. I know it's a section a lot of you sometimes have a bit of a hard time with, so hopefully today, once we've worked through it, you'll see that it's not a section that should be causing too much of a headache. Let's hopefully sort it out for you. Right, let's have a look at our first question for this morning. What we have got is 2 functions, okay, we've named them f and g, and f of x, that's going to be our x squared minus 2x minus 3. That graph over there is going to represent the parabola, that's the quadratic function over there. And the second graph, the g of x, that's representing our straight line graph, our negative 4x minus 6, okay? Before we get going, let's take a quick look at certain things. The standard equation here, if we look at the standard equation of a quadratic function, we've got ax squared plus bx plus c, okay? Our A is telling us whether our parabola is a positive or a negative, okay? And basically the short way of talking about it is that is it a smiling or is it a frowning graph, okay? If that value for A, the one in front of your x squared, is positive, we know that our parabola is going to be a smiling graph, as we have over here. And if the A is negative, we're going to have a frowning graph, okay? Our B is representing our shift, our left or right shift, and our C represents our y-intercept. So please make sure you know what each of those values represents. It's obviously important for your understanding. The straight line graph, remember the -4, the value in front of the x, represents your gradient, okay? -4, which is telling us we have got a negative gradient, and our negative gradient is always going in the direction from starting up and ending off down, heading off down into the graph. Okay, and once again, that -6 represents our y-intercept, okay? Right, so now we've got that all clear. Let's go have a look at the questions. Typical first question for a functions graph like this, the coordinates of point A and point B. So we're looking at point A and we're looking at point B. First things first, do you all recognize that those are 2 points sitting on my f of x graph? So we're looking at the parabola. So the equation that we are going to be working with is our parabola equation. Okay, now what the next thing we need to do is identify what type of points are these 2 points sitting on the parabola. And if we take a look at point B and if we take a look at point A, we should see that they are both your x-intercepts of your parabola. Those 2 points are where the graph cuts the x-axis. Any graph, doesn't matter what graph you are working with, to work out your x-intercepts, we say let y equal 0. Okay, so we're going to take my parabola equation, and let's just quickly remind ourselves, it's x squared minus 2x minus 3. So we've got x squared minus 2x minus 3. And instead of having y equals, I'm going to say 0 equals, because we are trying to find the x-intercepts. Now that we've got that, we have a normal quadratic equation. So we're going to factorize it. Factorizing it, we're going to have to use the factors 3 and 1. The 3 is going to have to be negative, and the 1 is going to have to be positive. Once we have factorized it, we take each of the brackets and we let them each equal 0, and we solve for x. Okay, so we end up with 2 answers for x over here, one of them being x equals 3, and the other being x equals -1. Okay, so let's go back to our picture for a second. I've got 2 values, 3 and -1. That clearly means that this point over here is going to be my value of 3, and this point over here is going to be my -1. Okay, please watch out. Look at what the question said. It said the coordinates of point A and point B. So if you left your answer like that, please understand that you haven't fully answered the question. If they want the coordinates, we need to give that to them. So therefore, our answer at the end of it is going to be this. Point A, which was our negative, the x coordinate is -1 and the y coordinate is 0. The b coordinate is going to be +3 and the y coordinate is 0. Okay, so that is now the answer completely, the question completely answered. Okay, now we are looking for the equation, the axis of symmetry of graph f. Okay, axis of symmetry, the line that is dividing your graph into a mirror image of each other. Okay, and that line over there represents our axis of symmetry. With a parabola, when it is in the form, when it is in this standard form over here, okay, the formula that we're going to use to work out this axis of symmetry is we are going to say x is equal to -b over 2a. Okay, I'm sure you guys all recognize that formula. What I would like to quickly just point out to you is that when we work with a parabola, that's one standard form in which the equation can come. However, there's another standard form, and that's that we can write it as y is equal to a x minus p squared plus q. Okay? Essentially, they are exactly the same thing. They mean the same thing. They've just been manipulated, and they look slightly different. Okay? The advantage, grade 12s, of it being in this form over here is that if we remember, the value of the -p and the value of the q form the coordinates of your turning points, okay? And the x coordinate of your turning point is always going to be your axis of symmetry. So, if your standard equation was in the form of a x minus p squared plus q, if they wanted your axis of symmetry, you are going to give them the value of the negative p, okay? However, if it is in the form of ax squared plus bx plus c, we are going to have to use the equation negative b over 2a, okay? Right, so what we're going to have to then do is use that formula. So, x equals negative b over 2a. That means that I'm just going to have to work sideways here. X is equal to negative, b is a negative 2 over 2a, which is a 1. That's giving us positive 2 over positive 2, which is 1, okay? If we look at it logically, okay, this is the halfway mark between negative 1 and positive 3. So this value over here, your axis of symmetry is 1. Again, let's make sure we've answered the question. The question said give the equation of the axis of symmetry. So your answer is therefore to say that x equals 1. That's the equation that we are looking for. Okay. Right, so far pretty easy. Let's have a look at the next part of it. We are now looking for the coordinates of C, which is the turning point of your F graph. Okay, so your axis of symmetry is automatically giving you the x coordinate of your turning point. Once you've got the x coordinate, and again, this applies to any function, if you've got one of your coordinates, if you sub it back into the equation, you will get the other coordinate. Remember, in any function, your x and your y work as partners together. So if you have the 1, by subbing it into the equation, you will get the other one. So always remember that. If you're sitting with 1 point, sub it in, you'll get the other one. Okay. Right, so that being said, we're now going to then find out what the equation, or the y value would be where the x coordinate is 1. Okay. So therefore, we're going to say 1 squared minus 2 times by 1 minus 3. That's going to leave us with 1 minus 2 minus 3. So we've got negative 5 plus 1. We should be getting negative 4. Okay, so what is the coordinates of my turning point? Let's go back up to our graph over here. The turning point, which is this point over here, we have now said is the coordinates of 1 and negative 4. Okay, look at your points. Do they make sense? Yes, they do. We're happy with that, so we can happily move on. Okay, if we're sitting with something that looks a bit odd, I would suggest you go back and just double check it. For which values of x is f of x greater than 0? Remember, guys, that this f of x is another way of referring to y. So what the question is saying is, where are the y values greater than 0? That's what it's saying. So let's look at our picture over here and let's see. If I were to highlight this portion of the graph over here, do you agree with me that all of those y values, oopsie, now I've moved it, all of those y values would be positive, okay? Let's take it away. There we go. And if I then went onto this side over here and I highlighted that portion of it, those y values are positive, okay? Everything between there, those y values are negative, okay? So those are not what we're looking for. We're looking for where the y values are greater than 0. So what is my answer going to be? This green portion is everything from negative infinity up to that point of negative 1 that we found just earlier. And then we're going from positive 3 off again into positive infinity. So the way we're going to write that answer is we are going to say that x is an element, okay? We're going to start from negative infinity and we went up to negative 1, okay? It said greater than, but it didn't put that extra little line underneath it, which means including, okay? So are we actually going to include the point negative 1? No, we're not, because at that point over there, it's neither positive nor negative. So we're going to leave it as an open space over there. Then what we're going to have to do is give that symbol, which is telling us that we're leaving a space between the points. And then we're picking it up again with a round bracket from positive 3 to infinity. Okay, right, so that is what your answer should look like. Don't let those kind of questions intimidate you. They're really actually not that difficult. You just need to understand what exactly it is that it's asking. For which values of k? Now, this is also one of those questions which if you actually just understand what they're asking of you, it's not that difficult, okay? For which values of k will f of x equals k have only one root? Okay, right. Only one root means only one x-intercept. That we first of all have to make sure we understand. So at the moment, we are sitting with two x-intercepts, point A and point B, okay? The only way that this graph is going to have only one root is if we took it and we moved it all the way up to there. So that if it was sitting like so, it would then have one root. Okay. Right. I want you guys to take a moment to think about that while we go for a short break.
Sure.
Think about it. See what we're going to do with it. We're going to carry on with it after the break.
Awesome. Another thing you need to think about is that competition question. In case you missed it, it will be running during the ad break. So make sure that you are aware during the ad break. See you after the break. Welcome back, Mindsetters. Hope you guys caught that question. Remember that when you do send it, remember the unique code that you need to answer it. And I'll repeat the code for you. It is 1862. 1862. Say this code when you answer the question. I know many of you are thinking, oh boy, what an easy question. Really, we're in matric now. But actually, if you tell us the unique code, then it gives you more of a chance to win. And there are many wonderful prizes, as you guys know. There's the CDs, there's a revision book, as well as this lovely t-shirt that I'm wearing. So answer the questions, guys, all throughout the show, and we will revise it at the end of the show. Over to you, Tamlin.
Thanks so much. Okay, so I hope you've all sat and stewed over it and as to what we are going to do with this question. So let's have a look. We said that in order for it to have one root, this graph needed to shift, or it needed to move, whoops, there goes our arrow, 4 units up. Okay, so it's going to have to move 4 units up. Now what you need to first of all have a look at, and this is the case with any question like this, okay? F of x, the equation of f of x is going to be this. We've got x squared minus 2x minus 3, that's the f of x part, and we're now going to make it equal to k, okay? With a quadratic equation, remember we want everything on the left-hand side. We want the right-hand side to be equal to 0. So what we're going to have to do is take that k and shift it over. So therefore what we're now sitting with is x squared minus 2x minus 3, and that's now going to become minus k, and it's equal to 0. Okay. We are focusing in on this part of the equation, the negative 3 minus k part. That together, the negative 3 minus k, makes up the constant term in that equation. So in other words, this over here now represents your y-intercept. Okay, so this is the trick, guys. We need to look at where the y-intercept is, and we need to look where the turning point is. And as we move that turning point up, as we said we needed to do to get to one root, so the y-intercept is going to move up with it, okay? And at the end of the day, the y-intercept is actually the one that we're wanting to watch out for and look out for, okay? So if the turning point at the moment, if the y-coordinate of our turning point was down at negative 4, do you guys agree we are going to have to move this up 1, 2, 3, 4 units to get it right up to the top over there? Now, if we did that, this y-intercept is, as the graph moves up, it's also going to move up 4 units. Now, the y-intercept of our graph, just from the equation, we should know is negative 3. So as it moves up 1, 2, 3, 4 jumps, it's going to go up to positive 1. Okay, our y-intercept is now at positive 1. And that would be the point where my graph has only got one root. Now, how do we tie this together? We take the equation, we take the part that we said we were focusing in on. So we take the y-intercept, which is negative 3 minus k. And when we moved it up 4 units, the y-intercept became positive 1. All right? Now that we've done that, let's solve for k. We're going to land up with, let's start with negative k, which is going to land up equaling 4. And if we get rid of the negative, k is going to equal negative 4. Okay, so the question said, let's just make sure we're with it. The question said, find the value of k. You guys agree that's what we've done. and we needed to find that value of k in order for our graph to only have one root. So once again, we moved we moved the turning point up. As the turning point moved up, so did the y-intercept, and that y-intercept was the part that we actually used to find the value of k. That's how that question works, grade 12. So if you can get your head around that, promise you those are how they work out, okay? Right, let's have a look at the next part. Okay, now we are going to be looking for the equation of g to the negative 1, okay? This notation over here, g to the negative 1 or f to the negative 1, is the notation that we're using when we're asking you to reflect the graph about the line y equals x, okay? Right, so let's take our g of x equation. G of x equation is negative 4x minus 6. That's my original g of x equation. I'm going to have to just get rid of that for now so we have a bit of space. Right, our g of x equation was g of x was equal to negative 4x minus 6. Okay. Right, the second you are having to give the equation of your inverse graph, the very first thing we do is we take our x and our y coordinates and we swap them, okay? So remember, that's your y coordinate over here. So we're going to swap them and we're going to have x equals negative 4y minus 6, okay? So you've swapped your x and your y coordinates, but you're not finished, okay? Please don't leave it like that. Any function has to be written in the form of y equals and everything else on the other side. So the next thing that we need to make sure we do is get y on its own. Okay, so that is going to mean that first things first, my negative 6 is going to have to come over my equal sign, and we're going to land up with x plus 6, which is equal to negative 4y. And once we have got that, to get y completely on its own, we are going to have to divide by negative 4, okay? So therefore, we are going to have x plus 6 over negative 4, which is equal to y. That is now the equation of your g to the negative 1. And if we were to actually draw that graph, it would just be the reflection of that graph, of the straight line graph about the line y equals x, okay? The next one's asking us to now actually sketch the curve of f to the negative 1. Okay. When you are sketching it, okay, this is now looking very confusing, so let's just eliminate all of this working out here. To make life easier, when you are sketching the inverse graph, work from your original graph, okay? Take all the coordinate points that you have on that original graph. And the great thing about this is all we have to do is just swap our x and our y coordinates, okay? So we had the points over here of, we had negative 1 and 0. We had 3 and 0. My turning point down below, it was 1 and negative 4. And our y-intercept was 0 and negative 3. Okay, so what we're going to do is we're going to invert them. I'm going to do it in a different color. It makes life easier. Right, so point A, if I've got negative 1 and 0, if I were to swap that around, it would be the coordinate of 0 and negative 1. So x is going to be 0, and y is going to be negative 1. So that's going to be my first point. We're going to call it A with a little dash above it to show that that's a translated point. Okay. The next point is going to be this one over here. If I've got 0 and negative 3, if we swap our x and our y coordinates around, it's going to land up as negative 3 and 0. So x is going to land up being negative 3, and y would be landing up being 0, and that's my new point over there. I've got 3 and 0, which if we swap it around is going to be 0 and 3. So x is 0 and y is, let's put him over here, y is 3. 0 and 3. That's my point B. And finally, point C was 1 and negative 4. We're going to swap the points around. So it's going to be negative 4. X is going to be negative 4. If we estimate, it's about there. And y is going to be 1. So we're going to put that around about there. Okay, so guys, all you can see all I've done is I've taken each point that was on the original parabola, and I took the x and the y coordinates and I swapped them around, okay? Having done that, we are now going to draw our line through here. and we're going to pass through this point here, and that point there, and there is my inverted graph, which now is going to be sitting on the side. If the question ever asked, is our inverted graph a function or a relation, okay, what would we say? If we're talking about a function, remember, a function is that for every x value, there is only one y value. So if you've got a normal parabola smiling or frowning, that's going to be a function. For every x value, there's only ever one y value. However, if you turn it on its side, that function now becomes what we call a relation. And how do we know that? If I were to draw a line, a vertical line, through any point on that graph, can you see that this y value has got more than one x value, and as a result, it's a relation and no longer a function. Okay, just a little bit of extra information there. Right. Finally, we get onto one of our teacher's favorite questions with regards to functions, and that's these good old lines, these vertical lines that we use. Okay, again, I'm going to just for now get rid of all of that. And what we're focusing in on is this line over here. Right, the vertical line PQ. Okay. Grade 12, the second you are having to find anything to do with a vertical line that is between two graphs, okay? Your starting point is going to be this. To find the distance from P to Q, all right? I want you to take the top graph and I want you to subtract the bottom graph from it, okay? So what that basically translates into, the top graph, the one on top at this point is going to be the one that's sitting on the parabola, and the bottom one is on point Q, which is the point sitting on the straight line graph. So what we're going to do to find the equation that represents this distance from P to Q is we're taking the parabola equation and we're minusing the straight line graph from it. So to find our distance from P to Q, we are going to take our x squared minus 2x minus 3, and we are subtracting my negative 4x minus 6 from it, okay? Please note, grade 12, that I have put this one inside a bracket. Why have I done that? Because the negative is going to belong to both terms inside that bracket. If you leave off the negative, immediately one of your signs is going to be wrong, and unfortunately from there it all kind of unravels. Okay, so please watch out, that negative belongs to both of them. So if we now distribute into the bracket, we can get our, okay? If we distribute into the bracket, we're going to say that PQ is equal to x squared minus 2x minus 3. That's going to become plus 4x, and that's going to become plus 6, okay? So therefore, when we simplify that out, we're going to have x squared, negative 2 plus 4, we're going to have positive 2x, and we've got plus 3, okay? All right, so with that, now we are going to be able to, that is now actually giving us the distance from P to Q. All right, another quick tip with regards to a question like this. Do you notice that the whole way down I kept writing PQ, 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 okay? The reason why is that there is a very easy mistake that can be made where just by habit, you make it equal to naught, okay? You say naught equals, and suddenly what everybody does is they veer horribly off the track because they then try and solve the quadratic equation. That's not what the question was asking, okay? The question very clearly said, determine the length of PQ in terms of x, okay? So in other words, what we were saying there is give an equation that represents the length from P to Q, but we want x's in there, okay? So please watch out that if you made this equal to naught, you are basically telling me that the distance from point P to point Q is nothing, okay? You're telling us that there is no gap between the two of them. And obviously you can see that that's not right. So watch out for that. Don't just make it equal to naught. That would be quite a fundamental mistake to make, okay? Right, and finally the question then says, what would the value of x be at which PQ would be a minimum, okay? Now, what we've got to understand is that if I were to take point P and point Q and I were to slide it between the parabola and the straight line graph, there's going to be points where it's longer and there are going to be points where it's shorter. And now we need to determine at which point is it at its shortest, okay? If I were to, for instance, slide it along to that distance over there, it looks like this gap is getting bigger and bigger. So I'm pretty clear it's not going to be heading in that direction. And as we go, okay, if we go closer to this point here, that's starting to look closer together. So we can sort of see where we're heading, but we need to know exactly what point it is. There's two ways to go about this. We can either use a little bit of calculus to help us out, okay, or we can actually just use the functions part of it. To save a bit of time, I'm going to use a bit of calculus here, all right? To work out the minimum value of PQ, what I'm going to do is I'm going to work out the derivative of PQ, all right? And if you remember when we work with minima and maxima in calculus, to find the minimum or the maximum, we take the derivative and we let it equal 0, okay? So on the side over here, if I find the derivative of PQ in terms of x, that is going to land up being, if we remember our calculus, 2x minus 2. That's going to be my derivative formula, 2x plus 2. Sorry, we're working from that formula there. 2x plus 2, and we're going to let it equal 0. So by letting it equal to 0, I'm going to have 2x plus 2. That's going to give us negative 2x, which is equal to 2. X is equal to negative 1. Now, I think we were pretty close on the mark there. If that was negative 1, we could probably see that that is going to be where that gap from P to Q is going to be the smallest. We haven't finished the question. Last thing we have to do. We've now established what the value for x is. We know x is negative 1, but the question asked, what is the minimum length of PQ? Okay? So in order to establish that, what we said earlier, if you've got a value for x, sub it into the equation, you'll get the value for y. So I'm going to take negative 1, and I'm going to sub it back into my original equation, okay, back into the PQ equation. All right, having done that, giving ourselves lots of okay, let's take that away. We are going to say PQ is equal to 1 negative 1 squared minus 2 times by negative 1 plus 2 times negative 1 plus 3. And that is going to give us 1 minus 2 plus 3, which is going to land up giving us positive 2. So therefore, the minimum length of PQ is going to be equal to 2 units. Okay? Same story every time you need to do that. So if you can recognize the question, top graph minus bottom graph, work out the equation. You can use calculus, the derivative equals 0 to help you then work out the minimum or the maximum of that length. And if you've got an x value, sub it into the equation. It'll give you the y value. Okay, how are we doing?
Yes, we're doing good. Let's go for a quick ad break just so that you guys can get refreshed and ready for our next segment. See you after the break. Welcome back, guys. I love that you grade 12s have come over to play with us today. Even better, we even have a mindsetter in the studio today because she thought, her name was Buntle, she thought that today you guys had to come here. Well, I know, that's just her because she's keen. You guys know that you are here and you are on the page, which means that, yeah, you could be sitting in the studio with us today. You're just inside a screen. So, hey, remember that you can Facebook us on the events wall for the question and competition, but you can comment on the show and ask questions on the show, and perhaps you have some questions to ask Tamlin or anything that you're not understanding, or even something nice that you'd like to tell us about your holiday. Our page is still open for that. We even have pep text today, and I'm sure that most of you have pep text going on your phone. Remember that it's R1 to join us, and you can chat anything. And also, you can email us. You can email us at win@learnextra to answer the competition question. I'm looking forward to the winners today. Over to you, Tamlin.
Thank you so much. Okay, apparently a few of you have got a question regarding my K question. So I'd like to just help you guys out a little bit, and let's just go back over that one. For those of you who understand, it's not going to do you any harm because there's always something to learn from it. So let's just quickly revise that question over there, okay? Quite a typical question, guys. So if you see it, recognize that what they're saying is they take your f of x equation and they're making it equal to a variable. Sometimes it's p, sometimes it's q, quite often it's k, all right? So just so you recognize it, okay? Right, the question again said that we're looking for the values of k, all right? If our f of x is equal to k and we're looking for it where it will have only one root, okay? when you're reading this question, that's going to be clue number 1. Okay, where they talk about one root, that's your first clue. Okay, so with that, I want you to go back to your question, and I want you to decide what will the graph look like if it only had one root. Okay, we're not allowed to flip it over or do anything like that. All we're allowed to do with this graph is either move it up or move it down. Okay, now remember we said that the turning point down below here was 1 and -4. Okay, now roots represent x-intercepts. That's what your roots are. Okay, and at the moment I have got 1, 2 roots. Now the question is saying we only want one root, all right? Now in order for us to only have one root with a parabola, it means that your turning point is going to have to sit on the x-axis. Okay, so that's the first thing that we have to kind of understand, is that what we need the graph to then look like is like so, where it's now only touching the x-axis. There's only one x-intercept. Okay, from there you're going to say to yourself, okay, if it had to go from there to there, it means that we had to go up 1, 2, 3, 4 units. Okay, that came from my y-intercept of my turning point, and it's moved up 4 units. Now, if the turning point is moving up 4 units, all the other points in the graph are moving up 4 units as well, okay? So the y-intercept, which was down there at -3, as the graph moved up 4 units, so the y-intercept is also moving up 4 units. And if I jump 4 units up from -3 to there, we land up at +1, okay? So the y-intercept, where the graph has only got one root, is at +1, okay? All right, I hope you guys understand that so far. So now that we've established that, let's go back to the equation and let's see what it was saying. Okay, we said that f of x, now f of x was the equation x squared minus 2x minus 3, and it's being made equal to k. Once you've done that, remember that you want everything on the left-hand side. You don't want that k sitting on the right-hand side. So we're going to bring k over, all right? Giving us x squared minus 2x minus 3, and that leaves us with -k equals 0, okay? Remember that the constant term at the end of your equation represents the y-intercept, okay? Now, the -3 minus k is the constant term of that equation, okay? Remember, this equation is in terms of x. So the variable is x, not that k is not going to be taken as a variable. Okay, so we have said that the y-intercept, where the graph had one root, was at +1. So therefore, we're going to take the y-intercept, the -3 minus k, and we're making it equal to +1, because that's where the y-intercept moved to. And from there, we're going to move over and we're going to solve for k. So if I move 3 over, we land up with +3. And that's going to give us -k is equal to 4. And to get rid of my negative, I'm going to put it by the 4. And again, that's how we got to the value of k. So I hope that that clarifies it for you. I know that sometimes it is difficult to understand it, but I hope you've written it down, and I hope that you go back and look through examples in past papers. I'm quite sure you'll find an example of that in your books. Go and practice a couple of those, but always remember that this part of the equation always represents the y-intercept, and that's where you've got to tie it in. What would the y-intercept be as the graph moves up or moves down? Okay, go and try them. They're easy to do. You just got to try them, okay? Right. Now we're going to have a look at something which also lands up catching quite a lot of learners, and that's if you've been given the parabola, but no equation has been given to you. You have to start off the equation by finding, or start off the question by finding the equation, okay? Again, there's a pretty standard way of going about it. So as long as we know our theory, if we understand the basics and the building blocks of our theory, the application really shouldn't be too tricky, okay? Right, if you have been given a parabola and you have to prove the equation, all right? This is how well, the first thing you're going to ask yourself is, what have I been given? Okay, been given. Because that question is going to help determine which route you are going to take to solve this, okay? With a parabola, there's two typical situations. You are either going to be given your two x-intercepts. You're going to be given the two x-intercepts and one other point. Or, and I'll do in the next question, we'll show you an example of this, or you will be given the turning point and one other point. Okay. For this particular question, what have we been given? They've told us that point A is the coordinate of -4 and 0. They've told me that point B is the coordinate of 1 and 0. And point C, all the way down here, has been given to us as 2 and -12. Okay. Right, so first question you asked yourself in your exam, you said, what have I been given? And you've answered your question. I've been given two x-intercepts and one other point. That means that automatically this is the next thing you are going to write down. We are going to write down y equals a, x minus x1 multiplied by x minus x2. Okay? Some of you may have learned it in class as x minus root 1 and x minus root 2. It doesn't, that's just a matter of how you write it down. Ultimately, what it means is that we're taking x minus the first x-intercept multiplied by x minus the second x-intercept. Okay. That is then where we're going to start. So we're going to say y equals a, x minus, now my x-intercept at a was -4, and x minus, the x-intercept at b is +1, all right? Then we're going to look at the other points, all right? The other point that we've been given is this point C over here, all right? Now, point C has got an x-coordinate of 2 and a y-coordinate of -12. So what we are now going to do is that into my equation, we are going to substitute y with -12. My x is going to get replaced with a 2. That now becomes +4. This x is also going to get replaced with the 2, and we've got -1. Okay. I hope you can now all see that the only thing left to actually solve for is the a. Okay? So we've got -12. I've got 6, and 2 minus 1 is going to give us 1. So therefore, we've got -12, which is equal to 6a. And if we divide it by 6, we are going to land up with -2 being equal to your value for a. Okay, great. So this is what we have now got. Y equals -2. That's the value for your a. We had x minus -4. So that works out to be x plus 4 and x minus 1. All right? And finally, we need to multiply that all out. So we're going to do a bit of FOIL. We've got x squared. I've got 3x, and I've got -4. And when we distribute my -2, we get -2x squared. I get -6x, and we get +8. Right, so we have now got the equation of the parabola. The question asked us to determine the value of the a, the b, and the c. All right? If we take our standard equation, y equals ax squared plus bx plus c, then we should be able to see that the a is equal to -2. The b is equal to -6. And the c is equal to 8. Okay. Right, so question, what have I been given? If you have been given the x-intercepts, the first thing you are writing down is y equals a, x minus x1 multiplied by x minus x2. The two x-intercepts are going to get substituted into your x1 and your x2. And the other point that you've got, okay, you will have another point on that graph somewhere. The other point gets substituted into the y and the other two x values, okay? That will leave you with a to solve for And once you've got that, then all the pieces of the puzzle start falling into place, okay? That's if you've been given 2x-intercepts, okay? The other way of possibly getting it is that if you have been given a parabola and you have to find the equation of the parabola, once again, first question, what have I been given, okay? Now this time what they've told us is that the sketch, point B is the turning point, and we've got the point there. That's the coordinates of 2 and -3. And once again, I've got one other point. Okay, so this time, if you have been given the turning point and one other point, the formula you are going to write down is y equals a x minus p squared plus q, okay? That should look relatively familiar. That's just the standard equation of a parabola in the p and the negative p and q form, okay? And from there, what we should know by now of this equation is that the negative p and the q form the coordinates of our turning point, okay? So let's take our turning point and let's substitute that in. So we're going to say y equals a. I've got x. Now, -2 is my x coordinate of my turning point, so therefore I've got -2 squared. Why is it negative? Because the standard equation was x minus p, okay? So it was positive 2 as an x coordinate, but when we put it into this point over here, that sign always changes, okay? And the y coordinate is -3. Having done that, just like we did before, the other points, the -2 and the 5, is going to get subbed into the x and the y. So -2 into the x and 5 into the y. So -2 into the x and 5 into the y. And once again, that leaves us with a to solve for. So we have got a, that's going to land up being -4, which we're going to have to square, -3. So we've got a multiplied by positive 16 minus 3. Okay, if I take my 3 over, we're going to land up with 5 plus 3 equals 16a. That's giving us 8 equals 16a. And 8 over 16, which we all know simplifies to a half, which is my value for a. Okay, sub it back into our equation, so therefore y is equal to a half x minus 2 squared plus 3. Squared plus 3. We can leave it like that if that's what the question is asking for. If the question is asking you for the value of the a, the b, and the c, okay, we're going to have to just multiply that out, okay? So multiplying it out, we're going to have to do a little bit of FOIL. So we're going to have to say I've got my half. Foiling out my bracket, I will land up with x squared minus 4x plus 4 plus 3. And we've got a half. X squared, we're distributing our half. If I distribute a half to -4, that's going to land up giving us -2x. And that's going to land up giving us +2, and I've got a +3. So last thing to do is just add our constant terms together. And that gives us +5. So once again, to answer the question that was actually asked, the a is a half, the b is -2, and the c is 5. Okay, so lots of things to ask yourself in an exam. Guys, if you are asked to find the equation of that parabola, the first thing you're going to say to yourself, what have I been given? Okay, 2 x-intercepts means you want to write down that standard equation with your x minus x1, x minus x2. If you've been given the turning point, you want to write down your equation with your -p squared plus q. Okay, if you remember these things, function is not quite the scary animal that everyone makes it out to be. It's really there's certain things that if we know how to manage it, it's pretty straightforward.
It is.
Okay.
I'm sure after this, functions will be your best friend, because Tamlin is here to help you. Remember that the competition is running during the break. You can still answer questions. So carry on with that and see you after the short break. Welcome back, Mindsetters. Because that was such a short break, I know that you guys managed to get in everything, and this is the last time that you can get in everything because the competition is closing. So I'm going to repeat the question one last time for you and allow you to just get those entries in really quickly. So the question is, what type of function is f? Of f of x equals 2x squared. F of x equals 2x squared. It can be A, a linear function, B, a quadratic function, or C, a hyperbolic function. So which one is it, guys? Make sure that you also give us the unique code, which is 1862. 1862, an answer on our Facebook events wall, just so that we get everything, and everything is great. I'm loving the way you guys are answering, and I'm loving the way that you guys are participating today. It is absolutely awesome. Hey, Tam.
Fabulous. Well done, everyone. Okay, right. So let's get on with our next question. So we've had a pretty close and thorough look at a parabola and how you guys are going to deal with those. And as I say, if you just understand your theory and if you know your rules, it's actually very manageable, and the questions you'll find land up starting to look pretty similar. So the key here is practice. You've got to go and practice many examples. Okay, the next type of function that we're going to have a look at now is our hyperbola. Okay, just let's very quickly look at our standard equation of a hyperbola. We've got y is equal to a over x minus p plus q. Okay. Our A is determining whether we're working with a positive or a negative shaped hyperbola. Positive, our two sides of the function will be in quadrant 1 and quadrant 3. Those would be if they were positive. Negative is going to be in quadrant 2 and quadrant 4. Okay, so these are the negative, and these are our positive. Okay, so that's what the A is first of all going to be telling us. The negative P, okay, that over there is giving us our x asymptote. Okay, and the Q is giving us our y asymptote. Okay. I'm sure many of us, or at some point or another, have taken two sides of a magnet and turned them the wrong way around and tried to push them together. And as hard as you try, those magnets just do not touch each other, okay? That's what I want you to think of when we see an asymptote, okay? The graph and the asymptote, we can try and they get close. They get infinitely close to each other, but they do not touch, okay? Your asymptote will never, ever be a point of intersection for your graph, okay? So when we work it out, what we'll always find if you're plotting your graph on your calculator is that if you've ever got a value where your asymptote is, you're going to be getting error, okay, on your calculator. Reason being because that function does not exist. That value does not exist, okay. All right, so we've got this graph over here. What have they told us about it? We've got -1. Okay, let's just point it out. We've got the graph that is sitting in quadrant 2 and in quadrant 4. So we agree that that is my negative function, okay, my negative hyperbola. We've got -1, I've got x plus 2, okay, so that is telling me that my x asymptote, here's the dotted line over here representing my asymptote, is going to be here at -2, okay. Please watch out when you're working with this equation. Again, this value, the standard equation is x minus p. The value of that negative p is always going to change sign. So if it's positive in your equation, it's going to be negative on the graph, and vice versa. If it's negative on the graph, when you put it back into the equation, it will end up being positive. Okay, so it just always changes sign. My y-intercept, my q, that's a positive q, so that's not going to change signs. Okay, the +4 is at +4, so that's my y-intercept over here, or my y-asymptote, sorry. And that's going to be at +4. Okay, so question number 1, a very typical question, is give the equation. Okay, watch the question that's being asked. Give the equation of the asymptotes of f. Okay, my x asymptote, that's the line passing vertically down through your x-axis, is at -2. What's the equation of that line? We are going to write x equals -2. And the y asymptote, the one horizontally running through my y-axis, is at positive 4. So the equation is y equals 4. Okay, right, so those are the asymptotes. Now they are telling us to determine the equation of the straight line of G parallel to the line passing through A and B. Right, let's look at our picture. We are looking for the equation of G. Let's give G another color here. Right, G is this line over here. We're looking for the equation of that line. Okay, important to note that it passes through that point over there. And they're telling us that it's parallel to this dotted line over here, which is passing through the point A and through the point B. Okay, right. Let's go through sort of a process over here. That is a straight line. Okay, if it's a straight line, we know that it's going to be in the form of y equals mx plus c. Okay, so now that we've written that down, we need to say to ourselves, okay, so that means I need to establish a gradient. I need to work out what the gradient is, and I need to work out what the y-intercept is. Okay, now why did they bother mentioning that this line is parallel to the line passing through A and B? Okay, the reason why that would be important, if we remember analytical geometry and in calculus, there's many times that this comes up, is that if any time two lines are parallel, they share the same gradient. Okay, so if it passes through point A and point B, what we need to establish is what is the gradient through point A and point B. Okay, that means that we need to use our formula y1 minus y2 over x1 minus x2. Okay, let's check if we have everything we need. Okay, point A is the coordinates of x is -2 and y is 0. So we've got that, that's great. Point B, I can see the y coordinate is 0. We're sitting on the y-axis, but I don't know what the x-intercept or what the x value is at that point over there. So before I can go ahead and actually do the gradients, I'm going to have to first of all just work out quickly what is the x value at point B. Okay, looking at your hyperbola, do we see that point B is the point where the hyperbola crosses your x at your y-axis? Okay, so in other words, it's a y-intercept, all right? And to work out a y-intercept, we take our equation and we let x equal 0. Okay, so if we take our equation and we let x equal 0, let's see what we get. -1 over 0 plus 2 plus 4, that's going to land up giving us -1/2 plus 4, and if we subtract 1/2 from 4, we are going to land up with 3.5. Okay, so that means that our y-intercept over here is at the point 3.5. So my x is 0. My x is 0 and my y is 3.5. Okay, that's going to help us out quite a bit. So now we are looking for the coordinates. So we're looking for the gradient. So we're going to say y1. So let's say 3.5 is my value for y1 minus y2, which is going to be 0, over x1, which will be 0, minus x2, which will be -2. Okay, so we've just done a normal change in y over change in x. If we simplify that out, 3.5, if we convert that to an improper fraction, is going to become 7/2. It's just sometimes much easier to work with it as improper. And it's over 2, all right? 7/2 divided by 2, all right? Then we're going to do a little tip and times sum over here. That's the same as saying 7/2 divided by 2/1, which will become 7/2 times by 1/2. Okay, so I did change my divide to times, and I inverted the fraction. And we land up with 7/4. Okay, so what have we got? We've got the gradient. Okay, if the gradient of my line through A and B is 7/4, that means that the gradient of my line G is also going to be 7/4. Okay, so what we now have got is y is equal to 7/4x plus c, and that c is our y-intercept. So now we got to find the y-intercept. Okay, looking at your purple line, we can quite clearly see that it passes through this point over here. And that point over there happens to be where the x asymptote and the y asymptote intersect each other. So if that line over there is passing through -2 on the x-axis, and this line is passing through +4 on the y-axis, then the coordinates where they meet each other is going to be at -2 and 4. Okay, so what do we do with coordinate points that we know? We sub them into the equation. So where I've got a y, I'm going to substitute 4. Where I've got an x, I'm going to substitute -2, and that is going to leave me with c to find, okay? And let's see what we've got. I've got 4, which is equal to, that's going to land up give us -14 over 4 plus c. 4 plus 14 over 4 is equal to c, and I think let's just quickly do this just to save ourselves a little. So we've got 14 over 4, and it's plus 4, which gives us 7 over 4. Excellent. So that works out as 7 over 4, running out of space. Okay, 7 over 4 is equal to c. So what's the equation of the line that we're looking for? The equation is going to be y equals 7 over 4x plus 7 over 4. Okay, right, so anytime lines are parallel, they've got the same gradients. If they're perpendicular, if anything gets mentioned about lines that are perpendicular to each other, just remember that the gradient of one perpendicular line multiplied by the gradient of the second perpendicular line, remember, will always equal -1. So just to give you that as extra information, if you're working with perpendicular, that's the way we would go about determining sort of any missing value that you are maybe trying to find. Parallel, as we worked out, parallel lines, same gradients. Okay, right. And now they've asked us for the domain of f to the negative of f of x to the -1. Okay. This is what I would suggest as a safe option to this. Obviously, we've got a shift here. We're moving left, we're moving right. Take that x to the -1. This is my standard equation. We've got f of x, which is equal to, we had -1 over x plus 2 plus 4. Okay. That was my equation. What I'm going to do is this. Instead of working with f of x, I'm going to work with f of x minus 1. Okay, so f of x minus 1 is going to be equal to -1 over, now instead of my x, we're going to replace x with x minus 1 plus 2, and then we've got our plus 4 on the end, okay? That's going to simplify to be -1. I've got x, -1 plus 2 is going to leave me with +1 plus 4. Right, so do you guys agree with what's happened here is that I've now got an x-intercept, an x-asymptote, which has changed, okay? If I were to draw a very rough graph, a very rough picture of what that would look like, I now have an x-intercept or an x-asymptote at -1. So -1 is going to be my x-asymptote at -1, and +4. That hasn't changed. That stayed where it was. It's just that the graph has now just taken a jump sideways, okay? So if this was my picture, it's a negative graph, so it's going to be in quadrant 2 and quadrant 4 still. But the question said, what's the domain? Okay, domain is how far is it stretching on the left, from the left to the right on your x-axis? What values for x satisfies the graph, okay? Now this arrow is telling me that we are going infinitely off to the left-hand side on this graph over here, and this arrow is telling me we're going infinitely off to the right on that side of the axis over there. So the domain as it stands is going all the way from negative infinity to positive infinity. Okay? We lost our graph here. There it is. Okay. So we're going from negative infinity to positive infinity. But there's one value that the domain does not touch, and that, must remember, is your asymptote. So if my asymptote is passing through negative 1, then what we're going to say for our domain is this. It's going from negative, so our domain, okay, is going to be an element from negative infinity all the way to positive infinity. It's covering all my x values from left to right, except for 1, okay, and that one x value which it did not touch was my asymptote. So what we then have to state is that the one value for x which it does not touch is negative 1. So we have to exclude negative 1 from the domain, because remember, that would be a no solution. We do not have a value for negative 1 for that hyperbola. Okay. Right. Are we ready for another question, or are we running?
Let's go for a quick ad break, just so that they can get everything in. Guys, remember that the competition, you don't need to remember this, I'm just telling you this, that the competition is now closed. I hope you guys got in everything that you needed to say about this question, whether A, B, or C, and we'll be announcing the winner live on the show after the break. See you now. Welcome back, Mindsetters. You guys see a brand new, beautiful face in front of me or next to me. Her name is Buntle. Tell us a bit about yourself.
Okay, hi, my name is Buntle Ndlovu. I go to Northcliffe High. I'm turning 18 actually in like a few weeks' time, like on the 12th of July. Woo, legal. Okay, no, that's just a joke. I am the idiot who came here and thought that Mindset Learn Winter School was actually a school. And yeah, but they've been super awesome here. They've been like family. They sat me down. I also watched the programs. It's been really awesome.
That's good. That's good. Guys, don't come here. I mean, we're in the studio, yes, but you can be on our screens. Buntle is just eager, and we love her for that. We love her. So you go to Northcliffe, you're in matric. How were exams?
Exams were fine, except paper 2, I think, for our school was like, I was seeing a different language. I don't know what was going on there. But paper 1 was obviously like really brilliant, like
that's
awesome.
Good. That's good. And that's why we are here, for those types of
if I don't get a distinction after this boot camp, I don't know what's going to go on. I don't know what's happening.
I'm sure you will. I'm sure all of you will. So now we'll be going through the challenge question or the competition question that has been up. I will repeat it to you, and then Tamlin will go over it nicely, just so that you guys can know exactly what's going on. So the question read, what type of function is f? F of x equals 2x squared. That's f of x equals 2x squared. Was it A, a linear function, B, a quadratic function, or C, a hyperbolic function? What did you guys say? I saw your answers. Tamlin, let them know, please, what goes on.
Well, if we've got an equation of y equals 2x squared, if it was linear, there would be no x squared. Okay, so if it was linear, it would just be in the form of y equals mx plus c, where my x would just be a plain x. Okay, if it was a hyperbola, your x, first of all, would not be squared, and secondly, your x would be down below. Your x would be underneath the fraction. So therefore, it is quadratic. Okay,
awesome.
So because it is squared, anytime you're working with any equation with an x squared, you've got a quadratic function.
Awesome.
Okay,
awesome.
You've got 2 roots.
And Buntle explained it in a nice, quick way as well. What did you say? Let us know.
I did say it was that answer, so
yes.
it's chill. But I just want to ask, can I ask a question?
Yes, sure.
So exponential will be if the x is at the top, right?
Exponential is where your x is in the exponent.
Okay.
Awesome,
Okay,
awesome.
cool.
Thank you for that, Tamlin.
Right.
Guys, I know that most of you answered the quadratic function, and those that answered it with the question, with the code rather, you guys answered brilliantly. I love that. I love that you guys were on the ball today. And also, Tamlin, if you want, we can do one other question that you feel that needs to be covered with functions.
Okay, one type of function which we haven't really had a chance to have a look at today is exponential. So let's have a moment to have a look at that, because what's nice and fun about an exponential graph is that it involves log graphs as well. Okay, so let's take a very basic exponential equation. I've got y is equal to the x. Let's just quickly for a moment, if I take our standard equation, I've got ab x minus p plus q. Okay, that would be our full exponential formula, all right? The P and the Q, this time, please just note that the P for an exponential graph is not an asymptote, okay? The P represents what we're going to call a horizontal shift, okay? The graph will pass through that line. It's just a shift to the left or to the right, okay? The Q, however, that over here will be your Y asymptote. So, in this case over here, if I've got Y is equal to 2 to the X, what we know is that there's no value for P up there next to the X. So is there a horizontal shift? No, it's just going to be a straightforward graph on our normal Cartesian plane. And is there any kind of shift up or down with regards to our asymptotes? As it is at the moment, no. What we'll do in a minute is we'll play with it and we'll add an asymptotes up and down just to see what happens to it. When we are sketching an exponential graph, what I would definitely suggest doing is using a table method. If you've got your calculators that can plot points on your table, great, okay? So let's do that for ourselves. I'm going to use my calculator. I'm going to put it onto mode 3, which is my table function, and we're going to type in 2 to the power of x, okay? We are going to say equals, which gives us a start value. That's telling us on our table the first value for x that we're going to be working with. 1 doesn't really give us enough looking at it on the left-hand side of our Cartesian plane. So I'm going to give myself a value of -5. It just gives me more space to work with on my graph. We're going to end at +5. I'm happy with that. It gives us a nice domain to work with, okay? And if we press equals, we're going up in steps of 1. And there's our table, okay? So where x is -5, y is 0.03. Okay, let's see if we can plot this graph over here. Okay. We're going to take... All right, what I'm actually going to do is I'm not going to plot the points exactly, otherwise I'm going to be backwardsing and forwardsing from that calculator. But let's basically see. What we know for sure is that we're going to pass through the y-axis at 1. It is an increasing function, so my y equals 2 to the x. Once you plot all of those points that you have on your calculator, it's going to look like that. Okay, all right. If I were to add a y asymptote to it, if I were to maybe say y equals 2 to the x plus 2, okay? What's now going to happen is that my y asymptote, which was on the axis down below, if that's 1, let's put 2 over here, my y asymptote is now going to move all the way up here. Which means that this purple exponential graph is now going to shift all the way up to go through here, where now the 2 becomes your asymptote, okay? If I were to add a horizontal shift into it, let's say I've got y is equal to 2 to the power of x plus 1 plus 2, okay? So what I've now done is I'm keeping my y asymptote up there at +2, and I'm also adding in a horizontal shift of +1. As is the case with a parabola and with a hyperbola, when you've got the p-value, okay, it's a negative p-value, so it's going to change sign. So when I take that +1 and I put it onto the graph, it is going to be plotted as -1. Bukle, do you remember that?
Yes.
Okay, right, so at -1, that's going to be where my horizontal shift is going to be put. Okay, right, so therefore my shift is going to be this, so everything is shifted slightly to the side, and my graph would then go up. And again, you can use your calculator to plot those points. Okay, that's allowed. All right, so that's your exponential graph. If it then said to you, give the equation of, if this was our f of x graph, so our f of x graph was 2 to the power of x, and they then went on to say to you, give f to the -1, okay? Okay, Burkle, now it's my chance to ask you a question. What do you do when we look for our inverse graph?
It's when you change the x and the y,
Well
right?
done. Look how good you are. Okay, put you on the spot. So you change your x and your y value. That's exactly it. So what we're going to do is, I'm going to take my x and my y and I'm going to swap them. So I've got x is equal to 2 to the y. But remember we said earlier, you can't leave it like that. With any function, your standard equation has got to be in the form of y equals and then the rest of it on the other side. So we now need to get y on its own. how are we going to go about, let's see if we can remember, how are we going to go about getting y on its own?
It's logs. isn't
It's
it?
logs,
Yeah.
okay. You are going to change it from exponential form to logarithmic form. So we're going to take y, which is the exponent. Now changing it from exponential to log form, we take the exponent in the exponential form and we make that the subject of the equation. So we say y equals, I've got log. Now the base of that exponent over there was 2. So therefore the base is going to be base 2 and we make it, and then we put our x over there. Okay. Right, so we have now got the equation of y equals log base 2 to the x. If we were to plot that graph, okay, very basically, I'm not going to do too much detail, but what we had is we had our graph of y is equal 2 to the x, which looked like that. The line of y equal x is the line passing like so through your origin. And if we were to then reflect that about the line y equals x, what happens with our log graph is it goes down like so, passing through 1 on your x-axis. And that would then be your f to the negative 1 graph. Okay, so your log graph is always going to be the inverse of your exponential graph. All right. Okay, have you got any other questions you would like to ask about functions?
Okay, I actually do. You know when you get the inverse of the graph and then afterwards it's not a function anymore. Just quickly explain how do you make it a function? I kind of forgot. Like,
an inverse often lands up not being a function, it's a relation, because by turning it on its side, remember the definition of a function, if for every x value there is only one y value. Okay, that would be our definition. So like a parabola, if it's a normal smiling or frowning parabola, for every x value you have only one y value, so that's great. The second you invert it and you put it on its side, it is no longer a function anymore, it's a relation, because if you were to do your vertical line test, I'm assuming you guys have learned that in class, if you do that vertical line test, the second that vertical line crosses more than one point on your graph, it's a relation. And unless you actually restricted your domain, okay, or your range, so that you landed up only having 1/2 of the parabola, that would then convert it back to being a function, okay? So you'd have to restrict it with a domain and a range.
okay,
All right.
got it.
Okay, there we go. I think we're all done with our functions for today.
Okay, awesome. Thank you, Tamlin, for a great show. Thank you, learners, for a great show, and Buntle for being here today. I mean, yeah, it was awesome. Guys, remember that we do have a winner today. We have a winner. We shuffled all your names and drew one out, and this winner was Xavier Murray. Xavier Murray, well done to you for answering the question correctly, and everyone else that answered the question correctly. Xavier, please email us the same way that you emailed us your answer. Please email us at win@learnextra, your address and your name and perhaps something that you'd like to say to us. Please email these details to us so that we know exactly where to send all your prizes. I want to remind you of your prizes. We have 2 CDs that Buntle kindly chose for us. I hope that you will love them. And we have our revision book. Here's our revision book. It will be maths. And we have my awesome t-shirt. Look at it. It's an awesome, awesome blue t-shirt. Let me get it. There you go. Here's an awesome t-shirt. And you can also read the back. And that's a wonderful saying for you and all you other mindsetters that answered the question correctly. And also another thing that I'd like to mention to you is that you need to keep revising, guys. It might be holidays, but school is soon. So you guys need to know. Prelims are coming for you, matrics.
Let's get
And
those distinctions.
there you go. Those distinctions. That means that there must be many of them. For every mindset show, we have a distinction. And guys, thank you very much for such a wonderful show. Remember that this is not the end. We will be back with maths literacy later, and the rest of the week will also be jam-packed. This was a wonderful boot camp, guys. And from us at Mindset, yeah, Tamlin, bye-bye.
Bye.
Bye, guys.